Hey everyone, I want to go over the answers for the percent composition worksheet that we did in class. Seniors, my mother left a note for you, so enjoy that. But this is the worksheet we worked on last week that has about 8 questions. So we're going to start with number 1. We're going to find the percent composition of the elements in copper 2 bromide. So the chemical formula for copper 2 bromide is CuBr2. And in order to do this, I have to first find the molar mass of the entire compound. So I'm going to add together the molar mass of copper and the molar mass of 2 bromine, because we have 2 bromine in that compound. So that would be 63.55 grams plus 2 times the molar mass of bromine is 159.8 grams. So that gives us a total molar mass of 223.35 grams. To find the percent of copper, I'm taking the molar mass of copper, and since there's only one, it's just one of them. So that's 63.55 grams divided by the total molar mass of the compound, 223.35 grams, and I multiply by 100 in order to output it into a percent, and I get 28.45% of copper. To find the percent of bromine, I'm taking 2 times the molar mass of bromine, which is 159.8, and dividing it by the total molar mass of 223.35, multiplying by 100, and I get 71.55%. And I know that is a good answer because the sum of those two percents, 28.45 for copper and 71.55 for bromine, add up to 100%. So that is a very good sign. For number 2, we have 3 elements involved. So we have sodium hydroxide, NaOH. First step is again to find the complete molar mass of the entire compound. So that molar mass, that's an N, is a sum of the molar mass of sodium, 1 oxygen, and 1 hydrogen, which is equal to 39.998 grams. For the percent of sodium, Na, take the molar mass of sodium, 22.99 grams, divide by the total molar mass of 39.998 grams, multiply by 100, and I get 57.48%. You may have rounded a little bit differently. I just usually like to carry about 2 decimal places just for good practice. But you may have rounded to 57%, and that is fine. For oxygen, we're taking the molar mass of oxygen, 16.00 grams, divided by the entire molar mass, which is 39.998 grams, multiplying by 100, and we get 40.00%. You may have used 15.999, that is fine. I just have a periodic table that says it's 16, and that's the one that was handy and that I was using, so that's why I used 16, but you should have gotten at least close to 40%. And then for the percent of hydrogen, we're taking the molar mass of hydrogen, 1.008 grams, divided by the total molar mass, multiplying by 100, and we get 2.52% hydrogen for this compound. Okay, number 3, we have ammonium sulfide. Its molar mass is 68.144 grams, and I got that by adding 2 nitrogens plus 8 hydrogens, because remember you have to apply that 2 outside the parentheses and multiply it by that 4, and 1 sulfur. So for the percent of nitrogen, I take the molar mass of 2 nitrogens, which is 28 68.02. Divided by the total mass, 68.144. Multiply by 100, and I get 41.12%. For hydrogen, I'm taking 8 times the molar mass of hydrogen, so I get 8.064 divided by 68.144, multiply by 100, and I get a molar mass of 11.83%, or sorry, not molar mass, percent of 11.83. And a molar mass of 1 sulfur is 32.06 divided by our total mass, multiply by 100, and I get 47.05%. And again, if you add all 3 of these percents together, you should get 100% as a total. And I'll move that so you can read it. Check your work really fast, pause it if you need to. I know that glare is not the best. And then finally on the front we have number 4. The percent composition of N2S2. The total molar mass of N2S2 is 92.14 grams. For the percent of nitrogen, I have the molar mass of 2 nitrogens, 28.02, divided by that total, 92.14, multiply by 100, and I get 30.41%. And then I have 2 sulfurs, so that is 64.12 divided by 92.14 times 100. And we get 69.59% for sulfur. Okay, so that is the front. It's pretty straightforward. On the back, we get to apply the percents that we found on the front and kind of work some problems backwards a little bit. And also find the actual grams of something in a compound. Okay, so number 5, basically someone has given you a chunk that is 25 grams of copper to bromide. We want to know how many grams of this is copper and how many grams of this is bromine in this sample. Okay, so since the compound is only made of copper and bromine, that's where all the weight is coming from, is copper and bromine. So my total sample of that chunk that they gave me is 25 grams. To find how many grams is made up of copper, all I have to do is multiply by the percent composition of copper. So going back to number 1, I already found the percent composition, and for copper it was 28.45. So I am going to multiply this by 0.2845. So I get an answer that is 7.11 grams. So in that 25 gram sample, 7.11 grams is copper, or copper atoms. The biggest mistake is multiplying 25 by 28.45. First thing I would notice is that I get an answer that's greater than 25. How can you have greater than 25 grams of something in a 25 gram sample? You can't, it's impossible. So that would be my first key that, hey, that's not right. I did something iffy here. Remember, percents are really decimals that are just expressed in a different way. So I always convert to a decimal to multiply by percents. Sometimes there's a percent key on your calculator that works pretty well, but it's pretty easy to forget to use it, so I always just convert to decimals. For BR2, we again have that 25 gram sample. We're going to multiply by the percent composition of bromine, which is 71.55%, or 7155. And that gives me an answer of 17.89 grams. Now when I add these two masses together, I should get 25 grams because the sample is only made of copper and bromine. So the total mass should add up together to be 25, and it does, so that is good. Okay, number 6 is very similar. We did a decomp reaction, how many grams of sodium ions and hydroxide ions would be produced. Okay, don't let the word ion freak you out. I'm just asking how much is sodium, how much is hydroxide, which is just O and H together. So don't let the words freak you out or anything like that. So I'm going to take the mass of my total sample, which is 34.25 grams. And first I'm going to find the percent of sodium. From number 2, I found out I had 57.48% of sodium by mass. So I multiply by 0.5748, and I get a mass of 19.69 grams of sodium ions. To find the OH, you could add together the percents of oxygen, hydrogen, and multiply that by 34.25. Or what you can do, since the remainder of the compound is made up of oxygen and hydrogen, is you can take 34.25 and subtract 19.69. Because remember, the remainder of the sample is just the sum of hydrogen and oxygen. And that should give you an answer of 14.56 grams. Okay, so that's how I solve for it, but you could add together the percents of oxygen and hydrogen, which would be 42.52, and multiply 34.25 by that percent. Okay, number 7 relates to number 3, so the percent composition of ammonium sulfide. We have a 14.05 sample of ammonium sulfide. How many grams of each element does this sample contain? So first I'm going to take my 14.05 gram sample. I'm first going to find the grams of nitrogen. So the percent of nitrogen was 41.12, so I multiply by 0.4112, and I get 5.78 grams of nitrogen. For hydrogen, again, my sample size is 14.05 grams. The percent of hydrogen was 11.83, so I multiply by 0.1183, and I get 1.66 grams of hydrogen. And finally, for sulfur, I again take my total mass, 14.05, multiply by the percent of sulfur, which was 47.05, and I get 6.61 grams of sulfur. So again, if I add all 3 of these numbers together, I get 14.05, and that makes sense because the sample is only made of nitrogen, hydrogen, and sulfur. Now number 8 is stated a little bit differently, okay? So number 8, we're actually working this problem backwards. So it says we find a sample of N2S2 that contains 3.5 grams of nitrogen. What is the total mass of the sample, and what is the mass of sulfur in the sample? So we have 2 questions to answer here. So basically, instead of taking our total mass of the sample times the percent to find the mass of just that element, they've given us just the mass of that element, and we want to find the total mass of the sample. So I'm going to set this up algebraically for us. So I'm going to make X the total mass of the sample. Remember, we multiply the total mass of the sample by the percent to find the grams of sample. For nitrogen in N2S2, the percent was 30.41, so I have X times 0.3041 equals 3.50 grams. They told us that in the problem. So now, if I divide both sides by 0.30141, I get X is equal to 11.51 grams. So that is the mass of the total sample. Then, to find the mass of sulfur in the sample, there's 2 things I can do. I can take 11.51 times the percent of sulfur, which is 0.6959, and I get 8.01 grams. The other thing I could do is I could take 11.51, subtract 3.50, and I get 8.01 grams of sulfur. So either way, if I multiply the percent or just subtract by the elements that I already have, since the remainder is sulfur, I can solve this 2 ways, and both ways give me the same answer of 8.01 grams of sulfur. So those are the answers to the percent composition worksheet. Let me know if you have any specific questions or anything like that. We will get more practice with these percent compositions later.